Hi students, today's lab experiment is fourth experiment, that is natural language processing. So we are using a pre-trained model, deep learning model. Using that model, we'll do sentiment analysis, language translation and question answering. I'll directly go to the program in Google Colab. So here is the program. In the first line, we are installing transformers library from Hugging Face. So this library is a specialized library for NLP, computer vision, audio processing and multimodal application. I have already executed this cell. So once you execute these statements we are getting. From transformer library we are importing pipeline function. See, we have the pipeline function here. So this is a pre-trained model. Pre-trained model for any statement. That statement using a data set as a phrase. So our earlier model will simply count tokens, means words. Based on the words, positive, negative, like that, it was categorizing, correct? Here, statement wise, it is categorizing into positive and negative. So after running this line, this sentiment analysis function is loaded into this variable, sentiment pipeline variable. I have added theoretical portion along with this code. By reading this, you can easily understand. So this transformer function automatically load the pre-trained model. The model name is Stanford Sentiment Tree Bank, SST2 dataset. You can check in the net. This dataset get trained for each sentence. Okay, I can show you an example. The next cell, and these statements are trained positive or negative. Only as a binary it is trained. And along with each trained model, we have an annotation whether it is positive or negative. Now let us see one example. These are the text I have given. 4 sentence. I love the movie. This product is terrible. Negative. First one is positive. The product is blue. So there is no meaning for this. Third statement, without any meaning I have given. Fourth line, my students will get good job. So you can see the result. So we have executed a for loop here. The pipeline function takes each statement and it checks with the pre-trained statement, that is SST, this data set, SST2 data set. Based on the trained data set, we are getting this result. First one is positive, second is negative, it's a very clear statement. Third statement, the product is blue, correct? So it calculates a probability function based on the data set, it gives an answer, it gives us negative. Product is blue, there is no meaning for this, so it cannot be taken for a positive value. You can check with some other statement in this program. Last one is a positive statement. So I have shown a few sample statement here. Now we'll go to the next one. This diagram shows how this training is done in your SST dataset. So one example is taken. The example is the movie was not good. That is the statement. So you can understand this is a negative statement. So from root it divides sentence. The movie was left side, not good. So not is added with good, so automatically it categorizes to negative. The movie was is positive. Again next tree model, the next tokens are taken, next tokens are taken, like that. From with each sentence an annotation is added whether it is positive or negative. Now this 4 statement will help you to understand how this training model is working. First it takes each sentence, converts to tokens. How many words are there? That many words are tokens, convert to a numerical value. Then this model implements a machine learning model. Based on the machine learning model, each functions, each word the combination probability values are calculated based on softmax function. Which probability is more, the label is assigned, whether it is positive or negative. So here we are getting four different results, four results, that is 3 positive and 1 negative. Now let us take one example. In this model there are some default translation we have, that is English to French we have, English to German we have. For any other model we have to import the library separately. So the first cell converts to French. The translator takes pipeline function translation en to fr French. Statement is I am very happy. Now this translator will pass the sentence, length is defined, and the translation text. So that text is printed here. Here we can see the output English and French. One more example is taken, that is to convert to Hindi. So that package should be specifically mentioned. If you don't mention this package, it converts only the default language. So this translation model, Hindi we are giving same statement, input statement. Now we can see the output. By running this cell you will get Hindi output. Okay. Now question answering type. How this NLP is supporting for question answer type. So it takes a context, means a paragraph of input it is taken. You can see this about Bengaluru, I have copied the text. Now we'll run this model. Question is, what is best in Bengaluru? So this question I want to ask for this pre-trained model. Now you to get the output for this, we have QA the underscore pipeline function we have. So we are passing the question and to this context also we are passing, and we are getting an answer, that is what is best in Bengaluru based on my context, Indian classical music and dance. So here when the context is given about Bengaluru, given some 2-3 line, then here the best part of Bengaluru like classical, dance, music, informations are given. So based on this output is coming. Now you try to understand how this answer is formed. So the explanation is here. As I told, every sentence will be converted to token. Now contextual meaning should be identified, right? And contextual based token should be combined and the answer should come, correct? So step 1 pre-processing, we are doing tokenization. Then these tokens are converted to a numerical value, that is vector value. Now how semantic meaning is identified, that contextual meaning. You can see the statement, this model will analyze the relationship between word in the question to understand the query intent and identify the potential answer. Means probability of each tokens are identified along with its next word with context. So this model is already trained model used in transformer. Based on the maximum probability, it gives you the answer. For example, best in Bengaluru. Now you can change the question, best entertainment in Bengaluru. If I have mentioned any statement related to entertainment, it takes those words based on the maximum probability. Then the next maximum probability word, the next one, like that, a sentence is formed. So that is given the output here. You practice this program. I will share the program in Google Classroom. You practice this program and upload the output in the Google Classroom. Thank you.